Okay, welcome to today's class. I'd like to start with a startup off of the end of Chapter 2, Section 2.8. So try these startup problems and then check your answers. Okay, on the first one here, you were asked to show that f of x, which is 2 minus 5x, and g of x, which is 2 minus x over 5, are inverses of each other. You can do that by composing the two functions together. That's what the inverse property that they ask you to use, the inverse functions property, that's what that is. So if we compose f of g of x, or if we do g of f of x, you don't have to do both, you just have to do one or the other. We need to show that that simplifies to just be x. So I'm going to do f of g of x, which means I'm going to put the g function into the f function. So I'm going to take all of this and insert it here where the x is. So f of g of x is going to be 2 minus 5 times 2 minus x over 5. This 5 and this 5 will cancel, so I'm going to have 2 minus 2, distribute the negative through, so plus x. These cancel, and I end up with x, and that's what I need to have to show that they are, in fact, inverses of each other. Okay, the second problem asks us to show that the function, or to determine if the function absolute value of x was 1 to 1. If you remember, this is the absolute value function, so it is a v. So if I use the horizontal line test, it's going to touch it twice. So it's going to fail and therefore not be 1 to 1. The third one, you were told that f inverse of 4 is 7 and asked to find f of 7. If you remember, the function and its inverse undoes each other. So if the inverse maps 4 to 7, then the function is going to map 7 to 4. And then the last one, you're asked to find the inverse of the function. Here we have the 4x minus 2 over 3x plus 1 as our function. That we're going to have to find the inverse of. I'm just going to double check that I have it written right. Okay, so for inverses, we want to start out by replacing this with y. And you can kind of combine some of these steps together. Then we want to switch our x's and our y's. Okay, we want to cross multiply in a situation like this. So I'm going to have x times 3y plus 1. Be sure you put parentheses there. Okay, we'll distribute. Okay, we want to get our y terms together and our non-y terms together. So I'm going to take and move this 4y over, and I'm going to move my x over. Okay, I want to factor out the y. And then I'm going to divide away everything that's here with the y so that I can get y by itself. So I'm going to get y is negative x minus 2 over 3x minus 4. And so that is my inverse. All right, so hopefully you got those right. If you're still having any problems, then reach out to me and I'll be glad to help you with these. Okay, today we're going to start Chapter 3, and the first section in Chapter 3 deals with quadratic functions and models of quadratic functions. So first of all, I get so many questions about why do we study things, and some sections are simply a building block to calculus. Other sections actually do have practical applications, and this is one of those. So in this section, why are we going to study these quadratic functions? A lot of times when you're finding dimensions of rooms, specifically if you're in some type of business class, you may be using quadratics in order to maximize your profit and minimize cost and so forth. Different models for physics and athletics are dealing with projectiles can be modeled by quadratic functions. So there's just lots of different situations that are modeled by quadratic functions. So to start out, a polynomial function is a function that's defined by a polynomial expression. And it looks like this. So a polynomial function would be things like x to the fifth plus 6x squared minus 5x plus 3. that would be an example of a polynomial function. We're going to look at these a lot in this chapter, but specifically today, we're going to look at quadratics. Quadratics are a type of polynomial function. So a quadratic function is only one that has a degree of 2. So it's only going to be up to x squared, and it's going to be of this form, ax squared plus bx plus c. So quadratic function is a special type of polynomial function of degree 2. Okay, in the past, we've looked at quadratic functions and how to solve those, and we looked at completing the square, the quadratic formula, factoring, and other methods. So in this section, we're going to focus more on its graphical characteristics and specifically looking at being able to put a quadratic function in standard form, or which is also called vertex form, so that we can figure out what the vertex is and therefore determine its maximums and minimums. So this is just the general form of a quadratic function. It's not very helpful when it comes to graphing a quadratic function though, so we like to put it in what's called standard form, or you may hear that referred to as vertex form, because simply it's very easy to get the vertex when it's in standard form here. So we'll be working with putting these in standard form by using the process of completing the square, and then once we have it in standard form, we're going to be able to determine its vertex, the direction it opens, whether it has a maximum or minimum, and so forth with that. So here, once it's in standard form, its vertex is actually HK. So this part, you're going to change the sign of the part on the inside, and then you're going to keep the sign of the outside part. So also in relation to this, the A is going to tell us whether it opens up or down. If you have a positive A, or an A that's greater than 0, then your parabola, which is the name of a quadratic function's graph, your parabola is going to open upward. If you have an A that's negative, your parabola is going to open downward. So over here on Desmos, I just want to do a very quick little demonstration. We've already talked about translation, so this goes very much with translation. So if we have a parent graph of x squared, then this is actually going to indicate we would have a shift to the right 1 and up 4. So if I take a vertex, and the vertex is kind of this lowest point here, if I take a vertex that would normally be 0, 0 on the standard graph, and I shift it over 1 and up 4, well, my new vertex is the vertex 1, 4. And so you can see by doing your translations of this original parent graph that that's how we get the vertex that we're talking about here. So if I happen to put like a negative 2 in front of this, you can see that it flips that graph. So as long as this A is negative out in front, it's going to flip it upside down. I could, if I had something that is greater than, as long as it's greater than 1, it's going to open up. So you can just kind of play around with it if you want to look at Desmos any and see how that works. So I want to get started here by looking at an example of putting it in standard form when our A is simply 1. So when we have just a 1 here, an understood 1 in front of it, how do we put it in standard form? So the steps that I've outlined here, the first step is we want to separate the constant. So we're going to be using the completing the square method, except since we're not going to be solving an equation, we can't take everything and put it on the other side of the equal sign. We're just going to kind of take this constant and shove it off to the side a little bit. So we're putting it over here to the side, and we'll come back and use it later. Our second step is to factor out the leading coefficient, and that's not the greatest common factor, it's the leading coefficient. So looking at these, just these two here, we want to factor out the leading coefficient. So since that leading coefficient is 1, I really don't have anything to factor out there. Okay, we want to work with this and complete the square just like we did before. So this is my B. So I'm going to take B and divide it by 2 and square that. And that's what I'm going to add inside this parenthesis. Okay, so that's going to be a negative 4 divided by 2. Square that, and I'm going to be putting a 4 inside this parenthesis. Okay, this is where it's a little bit different than what we did before. Before, we would add a 4 here, and we would add a 4 on to the other side. But with this, there is no other side. So what we're going to have to do with this is we're actually going to have to just offset it with the opposite sign. So we already had the 7 here. I added a 4, but to counter adding that 4, I'm going to subtract the 4 so that I keep it in balance. Here, it's important that this is a perfect square trinomial. So it's going to factor into 2 parentheses that are identical to each other. And then we can simplify this to just get the 3. We'll combine these two together and get x minus 2 squared plus 3. And so this is going to be the standard form or the vertex form for this quadratic function. So I can very easily look at it and determine what its vertex is. Its vertex is 2, 3. And I know that the A is 1, so that tells me it opens upward. Okay, so this is a graph. If I were to put this in my calculator and go through finding the minimum, because this is the lowest point here, then you may get something that looks like this. Just understand that that's the calculator's way of writing 2 sometimes when it can't quite get it rounded to 2 because of the way it calculates it. But so our vertex should be 2, 3, which is exactly what we said it should be here by putting it in standard form. Okay, here's another example. This one we're putting in standard form, but A is not 1. Okay, so A is something else. Here, A is going to be 2 in our example. The steps are the same. The first step, we're going to kind of push this 13 off to the side. We're not forgetting about it, but we don't want to work with it for right now. So we're going to move it off to the side. Next, we're going to factor out the leading coefficient. So my leading coefficient is 2. Keep in mind it is not the GCF, it is the leading coefficient. So my leading coefficient is what I factor out here. I'll take the 2 out, and that leaves me with an x squared minus 6x. Okay, we're going to complete the square now. So my b is -6. So -6 divided by 2 squared is going to give me 9. So that's what gets added here. So I just added a 9 that was also multiplied by this 2 out in front. So 9 times 2 is 18. So I need to subtract 18 to offset that. So I added an 18 here, and I've got to subtract it here. Otherwise, I've changed the value of the expression, and I don't want to do that. Okay, here we'll just combine 13 minus 18 and get -5. We will factor this. It should always factor, if you've done it correctly, into 2 identical parentheses that you can then write as that parentheses squared. So when I get it to this point, my vertex is going to be 3, -5, and it's going to open upward because it has a positive A for that one. Okay, some of the problems on WebAssign are going to ask for some additional steps with these, but I just wanted to go through. All the rest of it is a reminder to us, but you still need to go through and be able to do this. So the first one is to find an x-intercept. If you remember back in chapter 1, we talked about finding x-intercepts, and we said substitute 0 for y, but when we're talking about functions, y and f of x are equivalent to each other. So going back to our original function, which was 2x squared minus 12x plus 13, I'm going to put 0 in for the f of x or the y. So I end up with an equation like this. And we've solved equations like this before. If it would factor, you could factor it. If it doesn't factor, use the quadratic formula. So if I use the quadratic formula and simplify it, remember when I get down to here, I can simplify it by putting 12 over 4 to get 3. And then 2 over 4 would be like the 1/2 here. And depending on your directions, if it asks for an exact answer, this is going to be the exact answer. If it asks for it to be rounded to like 2 decimal places, then that's what you're going to give. Okay, for the y-intercepts, we want to substitute 0 for x. So going back to our original function here, if I put 0 in for x, I'm going to have 2 times 0 squared minus 12 times 0 plus 13. And so my answer would be 13. So my y-intercept is going to be 0, 13. Okay, so sketching the graph, I'm not real concerned that you do these by hand as long as you can put it in the calculator. You should see that we have a y-intercept here of 13, and our x-intercepts if you compare them, they would match up with those decimal answers that we had before. So this is what we would expect to have for our graph. As far as the domain and the range, we have talked about before finding the domain and range from a graph. So if I look at this, this is any polynomial's domain is going to be negative infinity to positive infinity, because these keep going out and in each direction. It's also going up, so that tells me the top side of my range is going to go to infinity. But I do need to figure out what the bottom side is, and that's where the vertex can be helpful. We know that we found the vertex to be 3, -5. So if this point is 3, -5, then it never goes below -5. And so that's going to help me identify what the range of my graph is. Okay, it's important to be able to find maximum and minimum values of quadratic functions, because just like we were talking about before, some of the applications of quadratic functions, sometimes you need to know like what is the minimum cost or the maximum profit or something like that. And so knowing that minimum or maximum value is really important. So the main thing I want to emphasize here is if it opens upward, so if you have an A that's positive, then you're actually going to be finding the minimum value. And keep in mind, value always indicates that you're finding the y or the f of x part to it. Okay, so we'd be finding the y coordinate of our vertex. Remember, our vertex is hk. So the minimum value is going to be the y coordinate of that vertex. By the same token, if it opens downward because we have an A that's negative, our maximum here is still going to be the vertex, and we take the y coordinate of that for the maximum value. So it occurs, the maximum occurs at H, and the maximum value is K, as far as how we interpret that vertex. Okay, so here's another one that I'm going to go through. We want to, first of all, put this in standard form and then find the minimum value of it. So if I'm going to put this in standard form, I'm going to start out with my function and kind of push the 49 to the other side. This will be 30. Okay, I'm going to take out my leading coefficient. Okay, I'm going to complete the square. So if I take my b, divide it by 2 and square it, then that gives me a 9 that I need to add. So -6 divided by 2 squared is going to be 9. So that's what I'm putting here. So to offset that, I put a 9 that was inside a parenthesis multiplied by 5. So I'm going to subtract this 5 times 9. Sometimes if you want to put 45 here, that's fine. Sometimes it's almost easier if you see what it is that you multiplied together and then offset that. So here we'll have 5 times x minus 3 squared. This will factor into 2 parentheses of x minus 3. And then this will be plus 4. So my vertex, this would be the standard form for my quadratic function. My vertex is going to be 3, 4. So looking at this, I'm not even concerned about sketching the graph. You could do that on your calculator. I am concerned that you can, first of all, determine if it is a minimum or maximum, and we would know the answer to that by knowing that my A is 5, which is greater than 1, so that tells me it's going to open upwards. So if I have a parabola opening upwards, then I'm going to have a minimum and not a maximum. So I would have a minimum here at the vertex, which is 3, 4. So as far as the minimum value itself, the value we said was the y coordinate, so my answer there would be 4. So the minimum value is 4, and it occurs at x equals 3. And you can see the graph here to kind of show what the actual graph would look like. Keep in mind that some of these parabolas are not going to have x-intercepts. So if you run into one on WebAssign where you're getting a complex solution, then it's not going to have any x-intercepts because it doesn't touch your x-axis. Okay, here's one that has a negative in front of it, so I want to go through the same process here. If we're going to put this in standard form, then I'm going to push this 2 kind of over to the side. I'm going to take out my leading coefficient, which is a -1. Okay, here if I divide my b by 2 and actually, okay, b divided by 2 and square that, so I'm going to get 1. So to offset that, I'm going to this one, I'm going to have a -1 times a +1. So I'm actually subtracting here. So I'm going to end up adding 1 out here to keep it in balance. So I have -1 times x minus 1, x minus 1, and then plus 3.